so system dynamics, the great father of system dynamics is J. Forrester. He's American electrical engineer by education. And once he thought, why don't we apply the laws of physics, in particular laws of electrical circuits, to processes that go on in economy, society, etc., etc. And that's how system dynamics was actually born. These are kind of main things behind these methods. So language includes things like feedback loops, stocks and flows, etc. But at the moment, probably they mean, or you cannot feel them really. So let's go to an example. This is a very famous and very simple model of innovation diffusion. It's also applied, well, when I say innovation, this could be, let's say, adoption of a new product that is launched in the market, or adoption of a new idea, maybe political idea. So, okay, let's say this is new product that has been launched in the market, and you're interested in how well it's selling. So you may start with drawing two stocks. So these are stocks. These are my clients, people who already bought my product. These are potential clients, people who may buy my products. So I'm interested in converting these guys to those guys, so moving them from here to here. So these are my two stocks, and as I sell, there's flow from potential clients to clients. So stocks and flow. Flow is another term in system dynamics. Now, why do people buy my products? What could be a reason to buy? And when I start thinking about it, okay, probably advertising is one of the reasons. So some people are influenced by advertising, and so they hear or see something and they buy it. This is one source of sales. Another source is word of mouth. People talk to each other, and that may be also a significant part of sales may come from here. So one guy tells another guy, okay, this is good stuff, you should probably buy it. So this is another, let's say, component of my sales, or another influence. So this arrow is flow. These arrows are influences. How big are my sales from advertising? I don't know. So probably, well, of course, they do depend on how big is the whole market. And let's say, let me introduce a new parameter in the model, advertising effectiveness, a numeric parameter. Can I measure this in the real life? No, I cannot measure, because in the real life, nothing like that really is, you cannot touch things like that. But I can still say, okay, I will have that kind of parameter in my model, and probably I will be able to find out its numeric value by calibrating the model. How big are sales from word of mouth? Oh, well, they certainly do depend on how frequently people communicate, how frequently that communication results in adoption, and also they certainly depend on the potential market. So that's the kind of typical system dynamics model. They are frequently drawn even just like on paper and not really executed, because one of the, let's say, the goal of that kind of modeling is to teach company managers to let them understand how things work and what affects what. But they also can be executed. Mathematically, they can be converted into a set of algebraic and differential equations, like my potential clients go down as I do sales, my client base grows, sales are sales from advertising and word of mouth, etc., etc. So let's build this particular model. It's easy, and we have time. So I'll use AnyLogic as the simulation modeling tool and build this model. We'll briefly discuss how it actually works. Right now, my interface language choice is English, but we do support other languages as well: Russian, Chinese, Deutsch, German, sorry, and Italian as a beta. So, new model, innovation diffusion. This is my canvas, so I will be drawing things here. And for this particular model, the methodology, the method is system dynamics. So I'll open the system dynamics palette. Now we'll draw a couple of stocks. So this is my potential client stock. This is my client stock. This is my sales flow. Initially, I have, let's say, 10,000 clients, potential clients, and 0 clients. I haven't sold anything yet. My sales rate at the moment is 0. So if I run this model, nothing's going to happen. I'm not selling, the clients still 0. So let's continue adding things to the model. So our assumption is that part of the sales are happening because of advertising. So I'll add a variable sales from ad. And we know that our sales from ad do depend on the size of potential market. And also we have this magical parameter, advertising efficiency, which I don't know what it is, but I'll just put in some numeric value. And I'll enter the formula that sales from advertising is the number of potential clients multiplied by this. For the time being, I'll say that my sales are just sales from advertising. That's probably it. Model compiles well and can be run. And you see that things are really happening now. My client base grows. My markets is, my potential markets is reducing as long as people are not returning to the potential clients. So yeah, things are really happening. Not rapidly, but somehow. What if we do add word of mouth influence? So it's from word of mouth. So another variable depends on the how many users are out there. My sales will now be the sum of the two. Sales from advertising plus sales from word of mouth. And how big are they? They depend on the contact rate. Another magical parameter that are introduced in the model. And so how frequently people do communicate with each other, and how convincing is their communication. Let's see. What's the fraction of contacts that results in convincing another person to buy? I can, just to be consistent with the presentation, this is our adoption fraction. Okay, so that'll be our, I'll just put in some value, 0.015, and the contact rate, let's say it's 100. Okay, so in sysdynamics, I have to visually draw dependency links so that the structure, these are actually formulas, as you can already guess, but these are language for defining those formulas is visual, and that's one of the principles here, that you should see explicitly what are the dependencies. So the formula for contact rate, there's a little bit of science in it. Sorry, for the, not for word of sales from word of mouth. Contact rate is a parameter. Let's put together a formula. Every client, user, happy user, during a time unit, a month, year, week, contact rate other people, but the other person, because clients do contact each other as well, and we're not interested in at all at this context, because we're only interested in whether a client contacts potential client. Therefore, we need to multiply all contacts with a fraction of potential clients in the whole population, and that'll be so this is the fraction of potential clients in the total population. Multiplied by the magical parameter adoption fraction. How frequently a contact results in a sale. This is kind of standard diffusion equation in the other way. So if you show it to any person who deals with, let's say, higher level consumer market modeling, or a modeling of infectious disease spread, etc., will easily recognize that. Let's run the model now. Oh, I have some errors. Clients. Yes, clients. That was my error. So sales are going on. This is, the dynamics is different now. This is the number of clients over time. This is the number of potential clients, and that is my sales curve. Can anybody explain why do we have the peak of sales and then sales go down? Yes? Absolutely, absolutely. So as long as we, at this point in time, if you see, let's say, 8 years or 8 months, whatever is the time unit here, everybody has become our client. Everybody bought the product. Potential clients are 0, and therefore we don't have any sales. And we have this rapid peak of sales here. Let's say the sales peak at about time 3. Let's say this is 3 months. Let's experiment with the model. I'll add a slider that will control ad efficiency, advertising. How much is company investing into advertising? Let's say from 0 to whatever. It's from 0 to 1. I'll slow down the model. I'll start it. And what I'll do after a while, I'll turn advertising off. I stop investing into advertising. And let's look at the system dynamics. Same thing, which shows that for this particular system, the really important thing is not advertising, is word of mouth, because see, the advertising was off during the most of the period, but we have the same sales dynamics. So what if we actually don't do any advertising? No sales are happening. Why?
Because there are no initial clients.
Absolutely, absolutely, because word of mouth cannot start working unless somebody actually buys the product for the first time. So these are simple things. And the whole system dynamics is that kind of stuff. Very abstract, very simple, very visual. Tools they're simple as well, because all you need to do, you just need to support a simple visual language. Very primitive numerical methods are behind this, formulas, and that is it. System dynamics models are, of course, not all of them are as compact as that, although there are some people like giants in system dynamics world that would insist that all models should be simple, and all big models are useless. But anyway, people do build huge models with hundreds of variables, trying to capture more things. People build small, compact, and visual models. These are very, very high-level things. And one of the main purposes of building this model is to teach people about how the dynamic system works. What really does matter and what doesn't matter. So, and that is let's say, the most high-level methodology in simulation modeling to date.